So we know that the equation of ID in saturation region is nothing but Kn by 2 V in minus Vtn the whole square. V in is nothing but Vgs, correct? In this case, we just saw that when my output was just beginning to fall, my input was VOH, so I can put Vi in or V in equal to VOH. This is nothing but V in equal to VOH, which reduces this expression to Kn by 2 VOH minus Vtn the whole square. Now let's put this in this general equation. We are interested in time from t equal to 0 to time equal to t1 dash, correct, minus CL. Output was initially VOH, output was going up till, so it was VOH, and it will be in saturation till VOH minus Vtn, and this is nothing but dV out. And let's put the equation of ID here. So ID, I'm going to take 2 up, correct, Kn VOH minus Vt of NMOS the whole square. Don't get confused, this is the equation I've just put it. So now we will have to integrate this, and after integration what we'll get is nothing but the following: T1 dash minus T0 equal to twice CL Vtn upon Kn VOH minus Vtn the whole square. So I got expression for this. Now I'm going to focus on T1 dash and T1 in the similar way, where I know that in this case my transistor is going to operate in the linear region. So let's quickly go ahead and do that. So here is case 2, where we have just seen that, like case 1, we are concerned with the time interval between T1 dash to T1. We have seen that the transistor is operating in the linear region, and my V out will be less than VOH minus Vtn, which I have already shown you in the graph here. When your V out goes lower than VOH minus Vtn, it will be in linear, and we are going to be concerned till V50 only because our definition is still here. So in this range between V50% to VOH minus Vtn, when my transistor is operating in linear, is the region which I am concerned with for integration. So let's quickly go ahead and do that. Let's write the equation of ID in the linear region. IDN is equal to Kn by 2, that's correct, twice V in is nothing but VGS, minus Vtn into V out is nothing but VDS, minus V out square. And in this case we know that input again is nothing but, if you look at it properly, my input is nothing but VOH. So let's substitute that, twice VOH minus Vtn into V out minus V out square. Now we are going to do the integration and put it in the general formula. So we have already seen that. So the initial time is T1 dash, the final time is T1 minus CL, the equation of ID, which I'm going to put it with the pink color here. But now what's going to happen is, here the equation ID is a function of the output voltage, so it also needs to be integrated, correct? Everyone agrees to that. So initial voltage where we are going to integrate is VOH minus Vtn, and we will go up till V50%, which will be the final. Look here, we start on this point and we go up till this point to find T1 dash to T1. That's exactly what I've done. And now I will put the value 1 upon Kn twice VOH minus Vtn into V out minus V out square. This whole thing is into dV out. This is the general formula, which again we saw here on the screen. This is exactly, I've just put ID, I've done the integration, initial voltages and the final voltages, initial time and the final time, and I have put it. Now after integrating, what we are going to get is the following. Let's quickly write after integration. So T1 minus T1 dash is equal to minus twice CL upon Kn 1 upon twice VOH minus Vtn ln is log of VOH, I beg your pardon, V out upon twice VOH minus Vtn minus V out. This is also we need to substitute the value of Vout, which is nothing but Vout equal to VOH minus VTN and Vout equal to V50%. Let's put this finally quickly.